Hey Ross, can you hear me now? Testing, testing.
Hello. Is that working?
That is working, Ross. Can you hear me also?
Yeah.
Excellent. Okay, perfect. Okay, great. I'll go back on mute. I'm just getting things final set up here, and I'll introduce you in about 10 minutes, or no, actually, about 15 minutes. Richard's going to go first.
Okay. So Richard's
Excellent.
saying it's too much content, and I'm a little bit. I don't think we've got an hour and a half's worth of content. So yes, it's quite padded,
Yeah,
but
no problem. I think,
it,
by the way, this is open to the world right now. There's a couple attendees, but James Carlisle
oops.
being one of them. Welcome, James. Um, Let me track down Richard real quick, and I'll chat with you on Slack real quick.
Cool. Cheers.
Thanks, Ross. Hey everybody, this is Mike Ward here from R3. We're going to get started in just a couple minutes. We're going to allow 2 minutes extra for people to join. So I will load up the deck and be back on momentarily. Okay, just testing if you can hear me, guys.
Yeah, hi Mike, this is London. We can hear you.
Excellent, thanks everybody. Okay, I think we're going to get started here. Let me quickly share my screen and we'll get going. For those who are on, by the way, it is possible now. If you, the first thing to share with you guys is we actually are live streaming this to YouTube. So we're trying a new format for those that have difficulty connecting with the plugin here. So that's available. It's also being recorded as you go up there. So if you wanted to rewatch this, this will be straight up on YouTube immediately following the session, which is great news. And let me project. So welcome everybody. Apologies for missing our last architecture working group. We had a mad rush to get 1.0 out the door, so this is a really exciting milestone, obviously. We are fresh off of our first release of Corda, which is an amazing milestone for all of us. And as you can imagine, the engineering team was out celebrating yesterday. So a few of them are back in the office, and we've got a few of them to talk again to immediately move on to work on the next release. So we had a couple of things to cover here today. First, Richard is going to talk about, in general, the Corda 1.0 release, thematically, what it's about, and what you can expect when you download it and start working with it. So really what we're trying to get out there for you. Ross is going to cover off confidential identities, something that's also come out in 1.0, so he'll go into a lot more detail on that for those that are not familiar with it. Roger's going to run quickly through how to move CorDapps into the 1.0 API stability framework here. So with 1.0, of course, the main aspect of being 1.0 is that API stability. So once you've made that migration to 1.0, you should have stability moving forward, which is great. So Roger's going to take you through some of the key things, having migrated a few CorDapps himself. And then last, Ross is going to talk and just introduce the concept of multiple identities in the Corda node, introduce some of our thinking on that, to solicit feedback from you all, particularly in the spirit of the architecture working group. So Richard, I'm going to start with you and pass you control. And I'm just going to leave a placeholder slide up for you. Let's see, make sure Actually, Richard, can you hear me still?
How about now? Can you hear me now, Mike?
There we go. Yeah, excellent.
Okay, some interesting features of Zoom. So we're actually lucky to have Mike Hearn in the room as well, who is over here in London to help with the release this week. So what I'm going to do is give a very high level overview of why we did 1.0 and what it means, and I'll hand over to Mike to go into a bit more detail about what the API stability commitment actually means, and some thoughts on where we go next with respect to Y stability and API stability. So there's several reasons we released Corda 1.0 right now, and why we called it 1.0. But the thing that I think is hopefully clear to everybody who's read the documentation and the accompanying blog post is that what we've called 1.0 is actually more exacting and harder to do, and something that will continue to be a big, almost a big tax on us for the future. In that it's not just an arbitrary number that we put on the front of the code base. We set ourselves, and I think we delivered the promise of committing to make the core API stable. So the application programming interface, and we documented this in the release notes, the core of it, we're committing won't change as we continue to improve, upgrade, and enhance Corda. And there's a reason for that. As we did our planning for the year in the late spring and summer, we were asking ourselves, what do we think needs to happen in order for people to be able to deploy technologies like Corda at scale repeatedly and successfully? And there's a sequence of things to actually get an application deployed. It's not sufficient that you buy Corda or install Corda. You've actually got to build your application. You've got to build your product or service that sits on top. So if you work backwards from when you take something that you think is going to make a big difference to the world and get it live, and work backwards from then, at some point you have to test it. Before that, you have to build it. Before that, you have to decide you're going to build it. Before that, you have to do some experimentation and POCs. And our assessment, and it's been borne out by what we've seen over the summer, is for people to make a large commitment to build on top of a platform like this or any other, they need to know that the work they do won't have to be thrown away or redone every week or every month when a new version of the underlying platform comes along. You have to have some predictability. You have to know that the base you're going to build on is stable. So the challenge we set ourselves, and which we hit with the delivery of Corda 1.0, was to give to the people, the large number of people and firms who are building on Corda, this commitment and certainty that applications they start developing against this version, as we upgrade it, they won't have to needlessly and hopelessly rewrite and rebuild their applications. Simple recompilation, and it will continue to work against the existing API. So it was a big deal, and it's part of the path to large-scale productionization. And already the feedback we're getting from people is, one, actually upgrading to it, because there are quite a few changes, is actually fairly straightforward, and Roger will take us through that. But also, speaking to people who built platforms elsewhere, or people who are building on top of it, they very much understand why we've done this, and they appreciate it. And maybe my last point, it may not be obvious, but not all version 1 platforms make this promise. And outside of Corda, I'm not aware of any other platform in the DLT space that won't continue to break apps as it gets upgraded. Corda is the only platform that's making that commitment. So we think it's a really big deal. It's not just 1.0. The API stability is something more significant than that. So that's the reason we did it, what we shipped earlier this week. It's now available to download, corda.net, as always. And with that, I'll hand over to Mike, who's got a bit more detail on it, but also what's not included and what comes later.
Okay, thanks, Richard. Yeah, so I want to add a bit of flesh to the bones of what Richard was just saying about what we are guaranteeing and what we're not, and when we will start guaranteeing more things. So what we stabilized in 1.0 is the core API. There are some other modules used for like unit testing helpers and so on that we didn't quite get there in time, but that's going to follow very shortly. And the goal is to have all the APIs that every application is using, including for things like that are not mission critical, but things like on the unit testing path. As well. Corda 1.0 contains a little web server, but that's not something that we're going to be supporting long term, because we want you to build on top of real web servers and frameworks like Spring, J2EE, Vertex, and so on. We're getting out of the web server business, but that's a very straightforward and easy migration as well, and one that almost certainly real applications are already making. So overall, we're pretty happy with the state of the core API. And some of the work that we're going to be continuing doing is around making sure that we actually check automatically that we are meeting that promise. This work has already got started. A few days ago, we checked in a change such that our pull requests are automatically scanned to make sure they don't change the public API. And this is now leading to good discussions within the team around exactly what does it mean to be completely API stable and so on. For example, do we actually want to be more stable than even Java? Well, probably not, because we're actually built on the Java platform. So that would be a bit pointless. You can't really do better than the platforms you're built on top of. And so we're going to be publishing more technical detail about what precise guarantees we're making, in the coming weeks. So what's next? Well, the next release is probably going to be 1.1 and 1.2 and so on. These are the maintenance releases which don't add features or any new APIs or major changes. They're just bug fixes, performance improvements, security improvements, and so on. The next release that adds APIs and new features would be, in our current thinking, version 2, and then version 3 after that, and so on. Right? This is a little bit. This is not quite the scheme called semantic versioning, semantic versioning is a sort of industry standard versioning scheme. The reason is that the first number in a semantic versioning scheme is usually x.y.z. The x number is incremented when you break the API, but we're intending to never do that. So it would always be at number 1, and it doesn't really make sense. So the next version of Corda, open source, that provides major upgrades will be version 2. Nice and simple. Applications can also find out which version of the platform they're running on, so they can query it to find out which APIs are available. Applications can also query across the network to find out which versions of the platform they're talking to, and also which versions of the applications they're talking to as part of the flow framework, and so on and so forth. So there's a fairly extensive amount of support for versioning and evolution of the platform in there. The next major goal is wire stability. This is about finalizing the network protocol and making sure that we can evolve the network protocol over the years without causing any problems. Much of this work has already been done. The original goal was actually to ship that in 1.02, but there are a few details that we didn't quite get to in time. That will be coming over the coming months. And a big part of that is a redesign of the network map component, which is well underway. The implementation of that is well underway to make it highly available, robust, resistant against denial of service attacks, and so on. So that's one of the reasons why we weren't able to ship wire stability in version 1, is that that redesign to be able to make it super robust, make the network completely indestructible, even against enemy action, is well underway and nearly done, but not quite done yet. So there's quite a bit going on, but of course we're now turning our eyes towards more features, upgrades, the non-functional requirements, and so on. It's not all about stability, right? So of course we've got to be implementing the features that people need as well, in particular around things like improved performance, high availability, disaster recovery, and so on, right? These things are being prepared in a mix of the open source release and our upcoming enterprise products. And we'll be starting to distribute builds of the enterprise product relatively soon. That is the plan. Looking to the longer term, we are we're ramping up our investment in SGX technology as well. We are doing more work on that, and the goal is to have that be ready by sometime next year. There's also, we're starting to talk to various companies and institutions that would like to do things like host nodes on behalf of other people, which is something that Corda was really intended for large institutions. That's what the product is currently designed for. But there's a lot of interest as well in smaller institutions, even down to the size of 2 or 3 man trading shops that would like to take part in the Corda ledger, but maybe not run the entire node themselves. And we are doing design work around how to enable that, how to unlock situations where administration of a node is actually shared between different companies. So there's a lot going on. And we're also, because the team has grown quite a bit lately, we're spending a fair bit of time on making sure that the team structure scales to our new larger size, getting ready to start delivering update releases, which will no longer be on monthly snapshots. That we'll be doing releases when we believe they're ready to go. And in general, getting ready for the next phase of the project's evolution. All right. So with that, I'm going to hand over to Rod, I think.
Ross now.
Oh, it's actually Ross next. Sorry, my mistake.
Yeah, Ross.
Gonna hand over to Ross, who will take us
Congratulations
through
to the team there.
confidential identity.
Perfect. So just double checking that everybody can see the slides here. And I think, Richard, you had noted that you can see it. So I'll just get a confirmation from you guys.
Yeah, we can see it.
Excellent. Thanks, everybody. So I'm going to pass over to Ross at this point. Sorry. Ross is going to present on confidential identities.
Yeah, so I'm about to, having just got that working, I'm about to share my screen, and hopefully we'll still have this working afterwards.
Sounds good. And
if I can actually get this to
you
open.
can take control from your end.
Cool. Just getting this open now. So it's share screen. There we go, display one. Okay, can everyone see that?
I can see it on this end. Thanks, Ross.
Great. Okay. So yeah, we've done a whole lot of work on confidential identities for 1.0, and I wanted to talk about what those are and how they differ from well-known identities and then the identities in Corda. Give me a second. There we go. So we have two types of identity, or two different ways of separating identity in Corda. So we have identities for legal entities, such as an organization or a business. They can be of a person, but it's unlikely to be in Corda. And we have service identities, which are used because you might have multiple organizations presenting part of the same service, such as distributed notary. Identities, in addition to being legal or service, can be well-known or confidential. A well-known identity is published and therefore is public, and a confidential identity is restricted to just those who need to see it. Three parts form an identity in Corda. So we have a name, and we're putting out rules on how these are structured. These are X500 names. If you've seen a SSL certificate where you've got CN equals ... that's an X500 name. A public key, obviously, so you actually got something to sign, so sign with, and an X59 certificate. So the same certificate as you have in SSL, and a complete path up to a network trust route. In the default case, that's going to be R3. You can build your own networks. Identities inside Corda code are generally represented with the party object. That doesn't contain the certificate or path. It's just a very quick shorthand with the name and the key. And as long as you take that from a trusted source, such as the Corda identity service, you know that's going to be valid. You can rip the name off that if you just want the key, and that's an anonymous party, and they both subclass abstract party, so they can be switched out. And finally, there's party and certificate, which is a party with the full certificate path to validate it with. So I touched on this very briefly. Well-known identities are made public. So you can look them up. You can say, I want to talk to Barclays UK, and you can go to the network directory service and say, sorry, network map service and say, what's the identity for Barclays UK? And it will give you the certificate, it will give you the name, all these details if you want them. Confidential identities are only provided to those who need to know. So your immediate counterparties in a transaction being the typical case. Potentially, if there may be a requirement that an output that was provided to a confidential identity in a previous transaction goes to someone later as an input of a new transaction. They might need to know that original confidential identity, but it's very restricted in who it actually goes to. It's not made public. So why do we have confidential identities? Well, quite often transactions in Corda will contain commercially sensitive information. They would expose things like such and such an organization is buying £1 million worth of this share, and that's very sensitive. And we have multiple approaches to providing privacy. These aren't the only defensive layer. Transactions are not broadcast globally. They're only sent to those who need to see them. Mike was just talking about SGX, so that's a major part of it, where we encrypt the transaction and it's validated inside a secure execution environment, but you can't by default access what's actually in it. So these are a third layer on top of those two to make sure that even if you did somehow get hold of that raw transaction, that you can only see keys which are generated on demand and therefore don't expose unnecessary details. So by default, you won't be able to work out who that key is representing unless you have their confidential identity. And there are examples such as the validating notary does get a full copy of a transaction, but is not part of it. Or as I said, people taking inputs that were previously an output will get a copy, or we'll see parts of that. We don't want to leak details that way. When do you want to use them? Pretty much everywhere, basically. The exception case is something like the Bank of England issuing some cash, where it is actually well recognized and it does want to specifically say, we did this. But normally, for example, if you're paying someone, or just pretty much any other context, you just want to use one identities rather than, so you want to use confidential identities, not well-known. Well-known identities must be used for messaging. That's just because the messaging layer needs to be able to know who to talk to, and therefore it uses the network map to find them. To create an identity, the node goes through this long process you can see here. It creates a new key pair. It requests that back, a certificate from the doorman service. The details it needs to build the certificate signing request are taken from the node configuration. The doorman validates the request, creates a certificate, sends it back. It's saved to the node's local key store. So when the node starts up the next time, it's all ready to go. It then creates an EDDSA key, which is used for signing transactions, and an ECDSA key, which is used for transport layer security between nodes. That's TLS. And there's reasons I'll talk about in a second, but these are separate. These are, and then the transaction key, that's the EDDSA key, is registered with the network maps. That's the default well-known identity for a node. Confidential identities are then created in a very similar way. You create a new EDDSA key pair. As the node itself builds an X59 certificate with a subject taken from a well-known identity. It may well be exactly the same. It may have differences in the with name CN field. And it's then signed by the well-known identity's private key to form a complete X59 certificate with a path up to the trust root via that well-known identity. The key management service's fresh key and certificate function does this for you. So you shouldn't have to do this. You just call that function and it goes away, does it all for you, and then gives you back the resulting identity. Something we're talking about internally at the moment is whether we actually do want to have two, whether we want to have two certificates issued within a node, one for TLS, one for one for TLS, one for signing, both on the same route, which is the current model, or if we want to split that into having an ECDDSA route for TLS and an EDDSA route for signing, and there's pros and cons to each approach. So the way we've done it unifies it at a high level by keeping it in one hierarchy, and the alternative would give us two simplified routes, but they would be two different routes. So something that if you guys can have a think about, I'd love your feedback at the end of this. Identity distribution, and I touched on this briefly earlier. Well, identities are public, they go to the map, everyone has a copy. If you don't have a copy, something's gone wrong. Confidential identities are distributed on a need-to-know basis. Need-to-know typically means that your parties in a transaction need a copy, and those receiving the outputs of a transaction as inputs to a later transaction need to know. We are currently putting in place policy handling for that. So you'll be able to say, I need to know about everyone in this transaction, or I only need to know the parts that I'm directly involved in this transaction. And those may be different cases. For the current model of disseminating or distributing identity, there's two flows that help. Swap identities flow does the creation and exchange of new confidential identities to be put into a transaction. An identity sync flow for distributing confidential identities you already created and have been used in a transaction. The APIs on these have not yet been finalized, so these are in the confidential identities module, and they will become part of the core module once they're finalized. Swap identities flow generates new transaction confidential identities. That's back to the key management service function we talked about a second ago. You would normally use it at the start of another flow, such as cash payment. And I'll use that example in a second. It's currently limited to working with exactly 2 parties. We will have a variation. It'll either be expanded directly to work with 3 or more parties, or we'll have an alternative for 3 or more parties. Again, that's the sort of API we're still hammering out. It takes in a party to exchange identities with and returns a mapping from well-known to confidential identities. We use a map because that may, if you've got 3 parties, 4 parties, it just scales linearly. And there's a very quick code example down here. And you can just see it's calling it a subflow, swap identities flow with our counterparty as its parameter. And then we pull the anonymous identity of the recipient out of that map. And that's just very simple. That's all you have to do. Identity sync flow is you've used a confidential identity and you need to let someone else know about it later on. Version 1's implementation serves all confidential identities the calling node knows about. For 1.1, we've locked that down. So there was a security concern that if a counterparty could convince you to include an arbitrary input into a transaction, and you might then expose confidential data that you shouldn't be. So it's now limited to only inputs that the calling node knows about. You have to call this multiple times for multiple nodes. You can see an example of this in the 2-party trade flow. Just before it collects signatures, it says, right, everyone, here's what the identities used are. So that collect signatures then knows, collect signatures on each party knows how much, knows who the identities actually belong to. Slightly more complicated usage, you provide a session, which is the counterparty to send it, or so session, 1 or more sessions to send identities to, and the transaction to actually extract those confidential identities from. If you need to do multi-way send, you would run it twice. If you need to do it across a broadcast, you would have to do, you'd have to trigger it from each party to all other parties. So it would be run, if you've got 3 parties and you need to send it around each other, it would run 3 times. Here's the example using the 2-party trade flow. It signs the transaction with the initiating node's keys, and then syncs to the counterparty node by sending them that transaction, just so it can pull that out and say, right, here are the entities used, here's what you might need to know about. And then the seller can say, okay, I don't know about that confidential identity or that one, please send them to me, and it sends them across. So I've put together a complete example with a cash payment. And here you can see the cash being issued to Alice's well identity because Alice self-issues this cash. And Alice is taking part as a bank here, basically. Alice then creates a new confidential identity and sends it to Bob. Bob creates a new confidential identity for themselves and sends that back to Alice. Alice builds a transaction paying cash to Bob's confidential identity they've just received. Then sends that to the notary service. Bob doesn't need to be involved at this point. The notary confirms it's a valid transaction, signs it, sends a signature back. Alice assembles a complete transaction with her signature and the notary signature on and sends a copy to Bob. And that's all it is. It's just a couple extra steps at the start of the transaction, at the start of the flow. Great, so you're using confidential identities, but now you need to actually resolve who someone is. So the identity service does this for you. Verify and register, normally you wouldn't call yourself. This is handled by swap identities flow or identity sync flow. You would only call this if you need your own policies on registering identities. Well-known party from anonymous does exactly what it says on the tin. So you give it a confidential identity and it gives you a well-known version back if you know who they are. Otherwise, it gives you null. And that can be null because you don't know who the well-known party is, or because there is no matching well-known party. And that's actually caused some confusion already. We've had a couple of cases where people went, why can't I solve this? But, well, because you don't know, you haven't had it registered, so you have no concept in Node of who that is. Further improvements. We want to make it even easier to use. So right now, there's still this you have to have these two different flows. We want it to work within the transaction builder. So you assemble a transaction using well-known identities, and you simply say to it, right, go anonymize yourself, and it will take that transaction with the well-known identities, substitute them, or find confidential identities for the counterparties involved, and do a substitution on the fly. There's also a concern that well-known identities are not different to confidential identities at a data layer, so you can't look at the X59 certificate and immediately tell what sort of identity you're looking at. So a flag, we're going to add a flag into the X59 certificate as some sort of extension, perhaps a complete policy. That's still under discussion. And if people have example policy they'd want to implement, that would be even better. Let us know. But that's the sort of thing we're coming up. And again, feedback on this design will be much appreciated. And that's it for confidential identities. I'll be back for another section later. And if you have any questions, I'll be talking in chat after this. Hope that's been useful.
Fantastic. Thanks, Ross. There are some questions in the chat. There's one question. Are the confidential identities on a per transaction basis?
You would create a confidential identity for a new transaction state, typically. So when you issue some cash, when you pay some cash, and IOU is a better example. Actually, Roger's talking about IOUs later. The person the IOU is issued by would probably be confidential, but that identity stays constant through the life cycle of the state because it doesn't change. Whereas the owner gets a new confidential identity every time the IOU moves owner. Does that make sense? Oh, that makes sense. So I don't think I can put up the chat without stopping sharing.
So if there's any other questions for Ross, by the way, we can revisit at the end of the call. But otherwise, thank you very much, Ross. That was fantastic. And Roger, I think we'll pass control over to you to talk about migrating CorDapps that have been written already to the 1.0 APIs.
Thank you, Mike. For those of you that don't know me, I'm the developer relations lead at R3, so I spend a lot of time building CorDapps and talking to members of the Corda community that are also building CorDapps. And what I'd like to do today is just highlight some of the main differences between M14 and version 1 of Corda. So what I'm going to do is share my screen, if that's all right, Mike, and I'm going to highlight my IntelliJ IDE. And hopefully you guys
we can see it, Roger.
Okay, perfect. So as Ross said, I'm going to go through an IOU flow. Though actually I've just renamed it here to obligation flow. And this is actually me rebasing the IOU version 2 CorDapp that some of you may have heard of before to version 1 like this week. So it's on my list of things to do. So one of the first things that I did was rebase the flows around issuing IOUs, now obligations. I also rebased the state object and the contract as well. But for the purposes of this exercise, I think it makes most sense to actually start with the state objects themselves. So you can see here that I've got a data class in Kotlin that represents the state object, this obligation, and it's an obligation. As it's an obligation, it evolves over time, and it's a bilateral agreement as opposed to something that is ownable. Therefore, I implement the linear state interface, and that's exactly the same as how you would do what you would do if you were using Corda M14. And of course, with the linear state, we have to override this linear ID property, and we have to override this participants property. So that's exactly the same as M14. There's no difference there. So for those of you that are familiar with Corda M14, you'll notice that there are two properties that have been omitted. The first one is the contract reference. So through the work that we've done on contract constraints, where now contracts will be added to a transaction as an attachment, we no longer reference the class of the contract within the state object. So you can see there's an absence of the contract property here. There's also no is relevant method. So is relevant was required because you might receive a whole bunch of transactions, but some of the output states in those transactions may not necessarily be relevant for you. So you would implement this is relevant function to ascertain whether it was relevant for your bolt or not. And what it would do is it would take a bunch of public keys that have been generated by the nodes and essentially just do a set intersection with the public keys inside the state object. Now that is done automatically by the platform, so you don't need to override that anymore. So those are the main changes for state objects. But now let's go into contracts. So this is a very simple contract that only currently only handles verifying new obligation issuances. And you can see, like in M14, it's almost exactly the same. You have your verify function. Here, I've just made it more modular. I split it up into multiple, well, there's only one now, but there will be multiple private methods to verify issuances or transfers or settlements, etc. And of course, we've got our commands interface here with some commands defined. But you'll see this new property here, which is the obligation contract ID. So this is a fully qualified class name that refers to the package that this class is in, as well as the class itself. And this is what you declare when you add an output state in a contract. That might not make so much sense now, but when I go through the flow, it will make more sense to you. But other than that, there are no real changes here. So what I'm going to do now is just look at the issue obligation flow very quickly. So just to give you a bit of context before I go through this code, imagine we have Alice and Bob, and off ledger, Alice has lent £10 to Bob. Now Bob, because he's a good chap, he issues an obligation to Alice in respect of the money that he has borrowed. So what he would do is he would start this flow by entering in £10 as the amount and putting Alice as the lender. Now there's this other flag here, anonymous, which is defaulted to true, and this is using the work that Ross has just explained to you around confidential identities. So in this flow actually allows you to issue an anonymous or a non-anonymous obligation, and I'll work through with you how those APIs look inside a flow. So firstly, you'll see that there's actually no changes to the progress tracker API. It is exactly the same. So no changes to make there. And there's no changes to initializing your flows. You still subclass the flow logic class. You specify your return type here, and you mark this as an initiating flow and a flow that can be startable by RPC. So as you know, that's important, because if you don't mark it as startable by RPC, you obviously cannot start it via the Corda RPC client. Anyway, let's go to the bulk of the flow, and as always, you define it inside the call method, and you specify the same return type as you do when you initialize the flow logic class. Now, the first line here, you can see is basically a switch on whether we set anonymous to true or not. If anonymous is true, then we call this private method create anonymous obligation. And what we do here is pretty simple, actually. which just following on from what Ross explained around this swap identities flow. What's actually happening here is that Bob's node is, the borrower is creating a fresh public key and certificates associated with that to link that random, essentially anonymous public key back to his legal identity. He is then sending that to Alice, and Alice generates a new public key and certificate, and then she then records Bob's certificates and key, and then sends her certificates and key back to Bob, who then also stores it. I'm just checking in the resultant map that is returned that there are two entries, one for Alice, one for Bob. And then what I can do is I can use the party objects. This map is keyed with party objects, and I can use the lender's identity, which is provided to the constructor of the flow, and our identity, which is now a class property of flow logic. So that's a lot easier than before. Before, I think you had to do service hub myinfo.legal identity. So now this is a more succinct way to get your legal identity, and you can look up your anonymous keys, and then instead of putting the party objects as well, actually, if we go back to the obligation, you can see that they take abstract parties instead of party objects. So this allows us to create an obligation that is anonymous, because we would use an anonymous party, or we can create one that is not anonymous just by using a party object. And of course, as Ross said, both of those classes subclass abstract party. So here we're adding anonymous parties, and then everything else kind of continues as usual. So what we do is we get a reference to a notary. There's a couple of API changes there. So there's a list of notary identities, and here I'm just getting the first available one, or I throw an exception if there's nothing available. Next, going on to the transaction builder, creating the actual builder class is exactly the same as before. However, adding an output state has changed. Instead of adding a contract state, so this obligation implements the contract state interface. So you would add an output state, which is a contract state, to the transaction builder. Instead, now what you add is either a combination of a contract state and a contract reference, or you can create a state and contract object which wraps both of those objects, the contract state as well as the contract ID as well. And what this does is it links the contract that governs how the obligation evolves over time to the obligation, and this is all wrapped up in a transaction state as well. So it's kind of almost the same principle as we had before with the contract reference in the state object, but this affords us more flexibility with contracts being syndicated around the network as transaction attachments. Adding commands and setting timestamps is exactly the same as before. You take a command data object as well as a list of public keys. Signing the transaction is exactly the same as before. So here I'm just passing in the unsigned transaction builder as well as our signing key, which is the borrower's public key, whether that's anonymous or not. And then we initialize the collect signatures flow. So the collect signatures flow just automates the collection of all your counterparty signatures, and that is the same as before, except now with the inclusion of confidential identities. You may have to pass one of the randomly generated public keys in there as well. And then finally, you call the finality flow as usual. The finality flow used to return a list, but now it just returns a single signed transaction. So once we've got that, we can just return it straight from the flow. And of course, the flow on the other side is pretty simple. We just subclass the signed transaction flow, and we call it as a subflow. And that's all we need to do. I guess for the purposes of this, I'm not adding any additional checking. So those are the main changes to the flow framework, really. I'd say the points to note really are that we now add an output state, a state and contract, as opposed to just a contract state, and the inclusion of this additional API for confidential identities is very useful, and actually it's very easy to use. As you can see here, there's not much additional code that you need to add to get those benefits. But as Ross said, we're still looking to make it even easier for you, so you can just anonymize a transaction via a simple method call over the builder. Okay, lastly, before I go, there's one more thing that I should point you to. So the Corda plugin registry is now no more. It has been replaced with the serialization whitelist. Because the only property, I believe the only method actually left in the Corda plugin registry class was a serialization whitelisting method, and that's now been replaced by this whitelist, which is just a list of classes that you want to add to the whitelist. So you would typically do this if you're using a class defined in another project that you can't annotate with Corda serializable. Everything else regarding the web server plugin registry is exactly the same, but as Mike mentioned at the beginning of the call, it's actually going to go soon, and we're going to replace it with I think perhaps a Spring Boot or something like that instead. So I think really that's all there is to note really. Yeah, I think that's it. So main things are there's no contract reference inside your state objects anymore. Is relevant has gone also. It's now done automatically by the platform. Inside your contract, you have to define this this string here, which is the contract reference ID. And inside your flows, you now have the choice of using confidential identities. And when you create your transactions, you need to be careful to include this contract reference ID. Do not do what I did, which is include the wrong the reference for a different contract, because you'll soon end up with a strange error there. So it's pretty important to be careful of that. And I think that's it for now. So what I'll do is I'll maybe go and have a look to see if there are any questions.
I think we're okay right now. So if anybody has questions, they can type them into the chat window. Unfortunately, we can't let everybody come off mute just for the number of attendees. But if you do have one, feel free to add it, and we can come back and Roger can answer after Ross presents. So we're actually going to touch on one subject also real quick, which is multiple identities. So Ross was going to talk to this conceptually to introduce the concept and solicit feedback from you all. So Ross, I'm going to pass back to you.
Cool. Yeah. So something we're beginning to work on at the moment, actually, and we have an internal wiki page that if you can get to, well, we'll talk about details about that later. So yeah, we're looking at being able to support multiple identities per Corda node. So for example, if you've got a hosting company that wants to host multiple organizations, or if you've got an organization that wants to host multiple different units within the same physical hardware, but they're operationally separate, you can do that. Now, there's a couple of consequences we're looking at for this, because a lot of the code has presumed historically that there is a primary identity to a node. And obviously, we're going to lose that, and the node then has just this bucket of identities. And I wanted to talk about these kinds of consequences. And if you have any concerns about it, there's a good time to raise them. If you've got any sort of feedback, this sounds like a really good idea, it sounds like a really bad idea, this is a great time to raise them. Or use cases we haven't thought about. So the node identities on a node are becoming just a big list of identities. For most purposes, you should already know the context you're working in. So the flows, when they're running, have a concept of the identity they represent. When you contact a remote node from a flow, you specify the identity you want to talk to. This is already used by the network map to actually find the node anyway. So, but it's just that what will start happening in a later version is that flow session initiation will say, I want to talk to this identity on your node. And presuming that identity is represented by that node, it will then start the flows up and let that flow know you're working as this identity. There are security implications of this. Obviously, you can't have the vault for one identity being the vault for another identity, because they'd be sharing cache and all these other resources. So we're looking at isolation between either having the vault service understand the current identity or have multiple vault services, one per identity. And any sort of concept of which of those trade-offs makes most sense, I'd love feedback on. Equally, let me know if there is a need for shared states in vaults. Perhaps for an organization that has multiple units, they may in fact have states that need to be shared. But then to me, I would say they're moved between vaults. They're not coexisting. And again, if you've got specific use cases, that's really useful for us right now because we're modeling this stuff out and thinking out how it's going to be used and what the implications are. I believe service identities being merged into this big pot of identities as well. So they'll be differentiated by name. And if you want to contact a distributed notary service, you would know what its full name is, and then you just pull that out of, you would actually pull out of the network map information for notaries, which is a specific case. If you had an Oracle service, you'd look it up by name as a better example. And everyone that needs to contact a specific identity needs to know their name, and we're providing search functions. So if you want to talk to Barclays UK, you'd be able to search for a name with Barclays in UK and get back a list of all matching identities and then pick the one that fits what you want to do. And I think this is beginning to fit. This will make sense when you see it. I'm hoping this makes sense. As I said, I'd love for early feedback. If you've got any sort of comments or discussion, please throw into the chat. I hope that's useful. We'll be presenting on this probably in a bit longer, in a few more weeks' time, when we've actually got a better fleshed out architecture internally. This is just very early stages. Let us know what you think, kind of stuff. I hope that's okay. Got any chat? Nothing yet. Oh, good one saying will be identity. Awesome, excellent, good to hear. And that's it for me. Back to Mike.
Hi, Mike. We can't hear you if you're talking. Are you still there?
Sorry, I was talking to a muted phone. Apologies. Thanks, Richard. So that's all for today's call. I appreciate everybody's time. We will send a follow-up email with now that we have everybody registering for the event. It helps us to follow up with more details. So we'll send links to relevant items. Thanks to all the presenters today, and congratulations to the team for putting out 1.0. So we'll join everybody again in 2 weeks. This video is up on YouTube already if anybody needs to rewatch it. And we will post a PDF of the slides up on the Corda.net website shortly. So thanks, everybody.